Good afternoon. Welcome to this afternoon's webinar. My name is Steve Buskell from Somerford Associates. I'm just going to outline the agenda, then I'll hand over to Ross, my colleague, to take us through the proceedings. Somerford are a specialist IT security and data management consultancy company based in Cheltenham. One of our specializations is higher and further education. We work with people like DFE, JISC, Exeter University, Plymouth, etc., etc. That's the end of any sales pitch you're going to get for Somerford. Just wanted to give a little bit of background to the subject matter today. I guess when we've been talking to various universities, colleges, and other education establishments, we've often heard that they would like to move or would consider a cloud strategy. They sort of quite like the flexibility that offers, the scalability of operations quickly and the cost savings. But certainly there is a reluctance from a security point of view to take that leap. And I think it's fair to say that higher and further education probably need flexibility, scalability, and cost reductions as much or more than most markets, but equally have massive sort of security concerns and requirements to protect data, to protect their students, to protect their staff, to protect their boundaries. So we thought it might be useful just to do an education webinar talking a little bit about the challenges and issues of moving to a cloud type environment, and then demonstrate a world-class solution briefly to illustrate how some of those challenges could be met. So questions, there's two options for questions. You can type into the question box at any point in time. Because we doesn't really work as we go through the demonstration to sort of answer questions live, then we've put aside a section at the end where we'll open up all the microphones that are currently on mute, and people can ask those questions live if they wish to. So either type in the question as we go along, and we will see them and respond to them within the demonstration, or save it up till the end and ask them verbally then. So without more ado, I'll hand over to my colleague Ross Asquith. Ross works for Netskope and is a cloud expert looking after a number of their cloud product solutions, and he's going to share with us, if you like, the challenges in the market today, and then talk a little bit about, at a high level, about some of the solutions that are available. So Ross, the floor is yours.
Thank you, Steve. Yeah, if you can pass me control of the screen, I'll start my sharing. That's what it looks. So let's see.
We can see the screen now.
That's great. I'm just moving my control panel out of the way. That's great. So thanks, Steve, again. So Steve says I'm kind of responsible for some of the product within Netskope. We're a cloud security solution, but I'm going to talk more generally about the use of cloud and the landscape, how it's changing, and what we can do to secure those types of environments. I quite often end up talking a lot about digital transformation, which is a bit of a buzzword. It seems to be my specialist subject, so we'll talk about that along the way as well. But I guess where I wanted to start was to talk about a comparison yesterday and today in terms of the way that we manage what was traditionally called perhaps IT security, now more commonly called cyber security or information security. In the past, we were able to construct a fairly rigid boundary to our business or our institution or our organization, which was designed to keep the bad stuff out and the good stuff in. So all of our efforts were focused on a perimeter, and that served us well. But as we look to today's world and how actually our employees, our students, whoever it is that we're responsible for are accessing the internet and the resources that the internet offers, we see a picture that's more comparable to on the right-hand side of this slide, where there's this interconnectivity between users and the applications they're using in the cloud, the websites they're visiting. Data flows directly between those places. We don't really have a perimeter anymore. We've kind of dissolved it, or certainly moved it. And if we drill down into that, kind of why that's happened, again, reinforcing this message of the old perimeter, the internet, the way it was used in the past was that the majority of what was on the internet was websites, if you like. So we've put some numbers on this slide. So let's say 85% of what was on the internet was websites, if we go back 15 years or whatever. And we governed access to that by using a perimeter that was generally constructed of appliances or software that our users had to proxy through or route through in order to be filtered. And our main goal was filtering. There was some perhaps SaaS applications back then, the early kind of SaaS solutions, things like Salesforce, I guess, were around back in the day, and IaaS. A very small amount of usage. IaaS being, of course, the public cloud providers, things like AWS, Google Cloud Platform, and Microsoft Azure, which have really come on, grown phenomenally over the past perhaps 5 years or maybe 10. So if this was a picture of the old days, again, let's look at what's happening today and what's forcing changes. Our perimeter becomes a little bit less relevant because of all this SaaS traffic that we have now, so people accessing cloud applications. Our kind of analysis of traffic that we see from customers using our services shows that about 85% of their internet traffic is now going to cloud applications rather than to websites. That's by volume. That's kind of how we measured that. And then we see 10% going to web now. So the balance has kind of shifted, and that's an important shift, and we'll talk about why a little bit later on. But most organizations we talk to, they can't deny this change. This is what's happening, and especially when you're in an environment where perhaps employees are being issued with devices, this direct connection between the device and the cloud is absolutely happening, and it begins to make this perimeter that has traditionally been maintained somewhat redundant. So I said I'd talk a little bit about digital transformation, and digital transformation is generally at its core all about mobility and cloud. They're the two things that are driving digital transformation, and either a business decides that it wants to digitally transform, in which case it looks to improve mobility and it looks to adopt cloud, or it finds itself being transformed because its users are actually going and adopting cloud without kind of IT's control, if you like, and they're beginning to use their own devices without IT's permission. We see it happening both ways. So this is a picture of what we see when we look at cloud. Generally in a large enterprise, and this is data from, again, garnered from our customers, we see well over 1,000 cloud applications typically in use, and they can range from the cloud applications that we recognize and know and love, things like Office 365 and Dropbox and Box and Salesforce, right through to all the cloud applications that we know from a kind of user-led perspective, things like Facebook and Twitter and so on, right through to the apps that we've never heard of that actually pose perhaps a risk if used within the organization, because they perhaps can exfiltrate data and end up placing that data out on the internet where we're not in control of it, and we may even lose ownership of it. So we'll make some examples later, but services like Zippy Share, which is a file sharing application that's not really regulated at all, and also things like PDF Converter cloud apps, where you upload your Word document and it converts it to a PDF that you then download. But what you obviously don't realize is where did my data go? And many of the T's and C's of those types of free services are very loose in terms of the assurances they provide as to how your data is going to be handled and what's going to be done with it. So typically of those 1,000 plus cloud applications that we see within an organization, about 2% of them are actually managed by IT. The rest, 98% odd, are either business-led, where a department within the business has gone and subscribed to a tool that's going to help them get business done, or user-led, where the user is using some form of consumer app. If you are, browsing the little list of icons that you see on this slide here, you might see some, cloud applications in there that you would think actually they're just websites. We see the BBC in there and the CNN and things like that, because the lines are blurring between what is a cloud application and what is a website. We can't think of websites as they were once upon a time, a very static resource that we just consumed by reading and navigating through. Even well, certainly sites like the BBC, we can high levels of interactivity, high levels of dynamic content within them. So even those websites, that 10% that we don't think is a cloud application, still has the potential to interact with the user in ways that we perhaps wouldn't have traditionally. And our main concern there is that somehow riskier behaviors will be performed by the user. Perhaps data can be exfiltrated from within the organization and so on to those types of websites, cloud applications. So the sorts of threats, I've mentioned a couple there that we kind of need to think about when we're operating in this kind of cloud world. I'll work around kind of anti-clockwise from the top. So, theft. If an organization has users within it that are intent on uploading data from inside the organization to out, then they could be doing that for malicious reasons. They could be looking to steal that data. Other times could be accidental. It could also be the case that if somehow our environment is compromised and an unauthorized third party has access to our data, they may choose to exfiltrate it by using cloud services. The reason for that is because they can usually guarantee that those services won't be blocked or access won't be prevented by things like a web filter and so on and so forth. Most businesses allow access to Office 365 or to box.com, and therefore it's a good route out of any organization, whether it's the user or someone unauthorized, as I say. The other risk over on the right-hand side, beg your pardon, on the left-hand side, is exposure of data publicly. So we know that even if we kind of buy into cloud and we decide, centrally and with proper governance that we're going to use Office 365, if I put data into OneDrive, if a user then chooses to share that data publicly from within that environment, that poses a risk perhaps to us. And as we've seen many news items, misconfiguration of public cloud infrastructure, so-called leaky buckets, for example, from AWS, can also cause embarrassment or worse. If you do, again, subscribe to applications that are sanctioned and you choose to store data within them, one of the benefits of a service like Office 365 is, of course, you can log into it from anywhere. That's one of the beautiful things about cloud. However, if a user is able to log in from a device that isn't managed by the organization, then they may be able to download data to that device. And again, as soon as they've done that, it's no longer in the cloud application that we had governance of. It's now on that end user's device. And for all we know, that could be their personal mobile device or an internet cafe machine. Who knows? The point is, it's now outside of our control again. So being able to, perhaps look at that risk and try and govern that is important. And then there's always threats in the traditional sense. So if the cloud provides new kind of vectors for delivering threats. One of the things we're seeing is, again, because of the likelihood that an organization won't block access to services like Box or Office 365, we actually see threats hosted within them. They become the place where a malicious file is held that a phishing email redirects to, if you like. And that's not just malicious files. We also see phishing sites hosted within things like AWS environments, because again, the person that's hosting that phishing site knows that access to that is probably going to be open, and it's very straightforward to host within those environments. You also have the benefit, for example, if you hosted a phishing site within Microsoft Azure, the user would end up connecting to a domain that looked like a Microsoft domain. It had a SSL certificate that was signed by Microsoft. It actually becomes quite effective to host phishing within these types of services, and it's something we're seeing more and more frequently. So I'm going to drill down into some of these use cases in a second, but what kind of happened in the market when people started adopting cloud in this way and these kind of concerns and risks started to emerge is that we ended up with a new little market sector. So some of you may have heard of cloud access security brokers, or CASB, and this was a term coined by Gartner, the IT analysts, and a market sector grew, and vendors fell into or developed solutions within this CASB space, which was designed to address a number of these kind of cloud-based concerns about that were emerging. So I'd encourage you to read the Cloud Access Security Broker. This is the Magic Quadrant you can read here, so you can see a report of what the market means and who the players are in that space to take a look if you like. So the sorts of things that a CASB could address, I'm going to run through. So people had concerns about, what applications are being used in my organization. That was one of the earliest use cases for CASB. I've already talked about, over 1,000 applications typically being used within an organization. It's interesting to see, where those applications typically or what departments are using those cloud applications, and we can categorize them. So we see quite a prevalence of HR applications within organizations, and they could be things like CV management systems, kind of where you use systems for applying for a job. We've seen instances of CVs infected with malware, macroviruses and such being uploaded into those types of portals, and then the HR department downloads it from the portal, and then suddenly you've got an infection inside. So the cloud's been used to inadvertently bring threats in. So, but you can see 139 HR apps or tools being used right through other categories as well, whether it's collaboration, cloud storage, so on and so forth. Getting an understanding of this is valuable to the business. And we probably want to understand from those applications that we see being used, whether we want them to be used. What's the risk associated with those cloud applications? Are those applications storing data outside of certain geographical boundaries? And that might be of interest to me if GDPR is relevant. What's the extent of use of these applications? So if I'm using Box and I see data uploaded, maybe that's okay because Box is my chosen managed cloud application, but I also see 143 meg in this example uploaded to some application that I just don't even know what that is. So how can I learn what that is? And various other kind of compliance type criteria. I'm interested in understanding about these cloud applications. Do they encrypt my data? Do they support multi-factor authentication if I want to? From a legal standpoint, if I upload my data to this application, do I still own it or do they own it? So we're going to take a look at an example of how we can score applications using these types of criteria and understand how good or bad or enterprise ready or not they might be a little bit later. So this is kind of use case number one for CASBs. There's also this concern that actually I've adopted a cloud application and I've put data in there, or someone's put data in there, and maybe it's the wrong type of data, or that the data I put into that environment is then shared further, exposed publicly, overshared if you like. So if we take an example of cloud storage, and I've named a few of the providers in that space, and we put some data into one or other of those, the sorts of data that I don't want to end up in that environment would be malicious files, things that may harm my business or destroy data, things that are regulated. So whether, if I'm a financial organization, PCI might be relevant. If we're operating within the bounds of the EU, GDPR might be relevant, and in which case I need to look for PII data and may not be allowed to or want to store that data within these environments. And then data that actually I'm happy being stored in the cloud because that's why I adopted this cloud service, but it contains maybe sensitive information, then what I'm concerned about there is that it doesn't get shared further. So we see this scenario where it's very easy for the user to click on this copy link or share this file. They create a shared document, they get a link just like this one, and they send it to the person they intended to share the data with. But what they don't realize is that the exposure is much wider. And forgive the cliched picture of the unauthorized third party, but here we see a link that basically can be accessed by anyone. And if you think this is a use case that's kind of what the chance is, then we see it a lot. In fact, I worked with an organization recently. They weren't a huge organization, a few thousand users, and their entire US team's HR data was shared publicly from their Dropbox account. So we actually discovered it, and there was about 400 employees. All of their kind of legal documentation, tax information, pay rise letters, it was all just there, publicly shared. Needless to say, they took that down fairly quickly, but it's easier than you think for this to happen. So this was another use case that CASB sought to address. We talked a bit about cloud infrastructure, so I'm not going to go through this one in too much detail because I think we've all seen these types of headlines, these AWS buckets or whether Azure blob stores or whatever they might be that have either been configured incorrectly so that the data held within them is now shared publicly, or they were rightly holding sorry, they were correctly shared publicly, but someone's put the wrong data in them. So either way round, you end up with a scenario where your data is exposed where it shouldn't be. And really the way to address that is to follow proper configuration guidelines and the recommended benchmarks to secure those environments. So I put a couple of references here, for example, to the Centre for Internet Security, the CIS, who publish benchmarks on how you should be configuring public cloud in order to avoid these types of misconfigurations. And CASB looked to monitor these types of environments. It was actually called Cloud Security Posture Management, or CSPM, where you could look into these public cloud environments and say, that's not configured according to these guidelines, or it's not configured according to the rules you set for yourself. And it would highlight that, because these public cloud environments, if they're being used within your organization, typically are quite fluid. Development work means that new instances and configurations and virtual machines and things get spun up and torn down very quickly, and trying to keep tabs on the security posture of those things is difficult. So hence, a special little requirement was kind of born out of that. We've talked about this one too, which is where, if I am using a cloud storage or a cloud collaboration app, it's very convenient for me to be able to access perhaps my email, outlook.com as part of Office 365, for example, or Gmail as part of the G Suite. Access that from any device. It's convenient, it's useful, and in fact the business may wish to encourage that. However, the second that I can click on the download button within an email, I've got a problem, because if that was sensitive data, then it's now outside of our control. My final use case, which was classically attributed to CASB, was exfiltration of data. So I'm worried about my users, my employees, whoever, being able to upload data from within the organization to what we've labeled shadow IT, which basically means the unmanaged applications that they're able to access. So I have some files internally, and I'm going to upload them to a PDF converter tool. I made reference to this just a moment ago. And when we look at the T's and C's of this service, and it talks about data obtained from the service being the property of our company, it talks about the company having no liability for failure to keep the data confidential. They're really, I guess you don't get anything for free, so this kind of free service has to have some sort of payback for them. So your data and you become the product, I guess. And obviously PDF converters is one place it could go, but it could go to some service like WeTransfer for transferring files. And our issue here is we may be okay with WeTransfer being used to share data with us. Maybe an organization that we work with, uses WeTransfer, and we need to get data that's sent to us in that way. But at the same time, we need to monitor what's being sent out via WeTransfer. And I'll give you an example of that in a little while around WeTransfer. So it's not as simple as let's just block access to WeTransfer, because you might actually hinder what the organization is trying to achieve if you were to do that. And if you did just block access to WeTransfer, you'll probably find that your users instead would use FileMail. And if you blocked access to that, they'd use ZippyShare. And the problem is there are so many of these tools, it becomes quite difficult to maintain or to manage blocking access to them using traditional kind of just block access kind of policies. And your users will just keep working around them. So better to find a way to enable the right kind of usage rather than just black and white blocks. And there's a special case, I guess, for shadow IT, which is where actually you have, and I'm using OneDrive as an example here, because this is a personal OneDrive instance. So if I've decided within my organization that I want people to use Office 365 and I want them to use OneDrive, I have a problem if they then log into their own Office 365 environment or their personal OneDrive account. And obviously the issue there is that my traditional controls would allow access to that because they're based at the domain level. They would say, yes, you can go to Microsoft.com or you can go to Office365.com or Office.com, whatever it is. That's where traditionally we would try and manage access, but that's completely useless if you want to try and differentiate between one instance or one account and another within the same service, which is just as bad as shadow IT. So that was kind of a summary of the traditional kind of issues, I guess, that people tried to address with CASB solutions. And this last example here, you can perhaps begin to see that I've been talking about traditional controls in this space, and what we're talking about here is being in line with the movement of data to these cloud applications. And that, of course, begins to overlap. It begins to overlap with secure web gateways. So I'm sure within your organizations, you're doing some form of kind of management or filtering of the internet. And if we look at secure web gateways, and this, it'll come around in full circle in just a moment. If we go back so when perhaps I cut my teeth in IT security, around the turn of the millennium, then we will recognize some of these names. So vendors like WebSense, they were born to filter the web, and it was all about inappropriate use and filtering content and stopping people accessing the wrong kind of websites, which is still something that people will do today within their kind of high level policies to block access to legal liability and things like that. But things have moved on, and back then we didn't have to worry about cloud. It was just about accessing the web. So then we could say that we had an evolution of secure web gateways. We reached 2.0, and this is where we began to see appliances from the likes of Bluecoat and ForcePoint and so on, filtering the internet, but also beginning to think about security and threats. So, the Secure Web Gateway 2.0 was all about threat protection in many ways. It was stopping people from accessing phishing websites, stopping malware and viruses from being downloaded from the internet. And we saw, vendors expand into that space and new vendors appear. As we move further, or rather more into the more recent past, and look perhaps just a few years ago, what started to happen was that these services that were traditionally appliances were now being delivered in the cloud. So just as people were moving their applications from their data centers to the cloud and using SaaS, the same thing was happening with security solutions. So vendors such as Zscaler kind of pioneered that kind of ability to be a secure web gateway, but to do it as a service offering within the cloud. And that meant you could scale things more easily, especially things like SSL or HTTPS, decryption, which traditionally placed a great deal of load on appliances that you perhaps had to maintain within your data center. So we saw an evolution there. And if you haven't guessed already, there's a 4.0, if you like, which is this cloud awareness that vendors like Netskope bring into the picture. So, if we saw a cloud-delivered secure web gateway previously, we're now talking about a next-generation secure web gateway. I know not everybody likes the term next generation, but it does kind of paint a picture of an evolution. And what do we mean by the next generation bit? Well, we're talking about the types of cloud awareness and the cloud understanding that enables us to meet the requirements that we walked through just previously, to actually control our data and the way that cloud applications are managed. And of course, that's necessary because of this growth of cloud applications, to the 85% figure that we mentioned earlier, from what was just static web pages. So what do we mean by kind of getting in line with traffic and understanding cloud and so on? How do we do that? Well, I've kind of made reference to it earlier. If you've got a traditional secure web gateway, it typically operates at the domain or URL level. So let's take an example here of some device or another accessing some cloud service or another. And in this example, I've picked box.com. And you can see if we ignore the lowest level of communication, which is kind of the noughts and ones of it, then if we look at HTTP, which is where the typical web proxy or web filter would operate, it's going to extract from the HTTP the domain that's being visited, and it's going to have to make a decision on just that. What we're really interested in is understanding actually what that cloud application is using to communicate with the client, which will be typically APIs, and they will be JSON based. So we're not simply following links, but we're clicking buttons and we're interacting with a dynamic page, and all of those interactions will be API calls of some description. And so if we want to get kind of smart about cloud, we need to understand those and decode them. So when you can decode things, you begin to see more of what's happening within that session to Box. So we can see, for example, here that we are seeing an upload of a file with a certain name. We can see the identity of the user, who they've logged into that service with, and perhaps some information about the device that they're using. Now, we may well see them log into the enterprise instance, which is the lower of these two decrypted sessions. But as you can see, this top instance is a personal instance. The only difference between these two transactions is the identity that the user used to log in. And if we can't tell the difference between those, as we talked about earlier, then you've got a problem, because the top instance is data exfiltration. If that's a sensitive file and it's being uploaded to that account, then I've got a problem. So I need to be able to decode properly these communications between the user and the cloud application that they're visiting. And obviously Box is one example of a well understood and actually a fairly secure app in itself, although that's not perhaps our instance that's being used. It is fairly robust. There are, as I've said before, plenty of other less enterprise ready applications where this file could be going. And I pick on ZippyShare again because it is one of the poorest scoring applications that we know of. And it's only one of thousands and thousands of applications, but there's other risk associated with my data ending up in that location. There's a little window on the left-hand side there, which is labeled CCI, which I appreciate is a little bit cryptic. So that stands for Cloud Confidence Index, and this is this is where we get an understanding of what the application actually, what am I trying to say? We get an understanding of how the application kind of scores on that enterprise readiness scale. Well, we're going to drill down into that when I'm going to show you a bit of a demo later. But we can combine that, with our understanding of what the user's doing to say, if I see a user uploading data to any cloud application that perhaps scores very badly from an enterprise readiness perspective, then maybe I should have some controls around that. So the takeaway from this slide really is that understanding of the APIs, the JSON between the users and the cloud. That's what you need to decode and understand if you want to be able to effectively manage the use of the cloud. And that's the NG bit of the NG or next generation secure web gateway. So here's an example. We've mentioned WeTransfer a few times. WeTransfer can obviously share files. I'll show you an example in a second. So there are some activities that the user can take with WeTransfer. They can upload files, they can download files, they can share files. And in this scenario, we're going to envisage that maybe those actions are taking place through Netskope service. So WeTransfer had a breach a month or so ago, back in June. For 2 days, on the 16th and the 17th of June, any files that were uploaded to WeTransfer and shared with an intended recipient were actually sent to what could have been just random recipients. WeTransfer to this day haven't really explained what happened or why, and they were unable to trace exactly where data went and to whom. So when something like this happens, if you're in the information security team within your organization, you may be requested by the business or feel that it's your duty to investigate this incident, and we're going to talk through perhaps where you'd head. So if you're not familiar with WeTransfer, it looks a bit like this. It's a simple interface. You go to the website and you say, this is me, and I put my email address in. I want to send this file to a recipient. In this case, I've used my Otto demo account. And then I click on upload a file and attach it. And the recipient then gets an email with a link in which they can use to download the file. That's how it's intended to work anyway. So it was this email that was being sent to random people by WeTransfer for those 2 days. So if we were trying to investigate this incident using our traditional controls, I might go to whoever administers my secure web gateway, my proxy, and say for those dates, so here's an example, for these dates, the 16th, 17th of June this year, I'd like to know, what data we may have transacted with WeTransfer.com. And this is the kind of an extract, a little screenshot of the report that you might get back. So maybe it will tell you who. In this case, 943 people, visited WeTransfer during those 2 days, and we saw some data uploaded and downloaded. And this is typically what you'd have to go on, which actually isn't particularly useful for trying to establish whether perhaps any of your organization's data has ended up somewhere it shouldn't. So contrast that with something that understands a little bit more about the cloud. So these are some screenshots actually from Netskope's solution, where we can understand a bit about the user. The important things on this little screenshot are, yes, I have a kind of corporate identity for the user because that's who they're authenticated to Netskope as, but also I see these fields below, the from user and to user. So this is where we're actually extracting data from the transaction that the user is making. So these are the identities that they've used to send and receive within WeTransfer. You'll also notice that we have far more information about the application. We're not just working on the domain. And this is critical in this example because actually if we look at the URL for WeTransfer, we can actually see that WeTransfer is hosted and operating on Amazon AWS. So actually our report for WeTransfer.com just tells us nothing about what data might have been uploaded or even if data was uploaded to WeTransfer, because the data that would have been uploaded didn't go to WeTransfer.com, it went to a completely different domain, a completely different service. So this is where knowledge of an application and the domains it uses helps us to actually provide more useful information. So we can establish the activity that was taken. Here you see the activity labeled as upload. So again, we can narrow our search. Maybe 943 people visited WeTransfer, but maybe only 10 of them actually performed an upload activity. So we're narrowing our field. And finally, if we wanted to go down right down to the data level, then you see here an example of a file that contains personally identifiable information. In this case, it's a little bit of a US-centric example with social security numbers, but you can see where we've extracted those numbers and references to personal information from the file. So depending on your policy and how closely you were monitoring the use of WeTransfer, you could be capturing data at this level, and that would obviously then let you confirm whether the usage of WeTransfer really was something that you have to worry about because there was sensitive data contained within the transaction. So if you were to build a platform that did all these things, what would it look like? And that's kind of how I'm going to build this slide out. So this is quite a fairly lively slide, so I'll go through it hopefully at a pace that makes sense. But we've talked about how the internet's used, and we've said there are cloud applications, both managed and unmanaged, that we want to perhaps govern access to, plus the traditional internet use of websites. And then these public cloud environments will kind of handle those specially as well. So in order to govern access to these, the easiest way to do it is with some form of cloud platform, something that sits within the cloud itself, so we don't have to worry about appliances and the like. And in order for that to exist, there needs to be some sort of infrastructure for it to run on. So these are Netskope's names for our architectural components. So we have an architecture we call New Edge, and our cloud runs upon that. Now, I've got users. Some of those users will be on devices that I own and manage, and that means that I can steer them into the cloud platform in order to govern usage of these things. So if I want to push through my next-gen secure web gateway for users accessing any of these internet-based services, I can do that. And it's at this layer, this platform layer, that I would enforce a policy that said that maybe certain websites can't be visited or certain data can't be uploaded and so on and so forth. That gives me my management of the internet, of websites. It gives me the management of cloud applications that are either managed or unmanaged. So it covers the shadow IT and helps me govern the usage of that. If I wanted more traditional CASB use cases, cover off all of those use cases that I went through earlier that were to do with CASB, I might need some slightly different architectures. So if I wanted to prevent data from being downloaded to those unmanaged devices that I talked about, the webmail where there's an attachment being downloaded to a personal device. In order to govern that, I need a reverse proxy architecture. It means that when the user tries to sign into OneDrive, I actually force them through the security platform so that I can control then what they do. And I also perhaps want to look at the data that's at rest within those applications that I manage, because I want to check and see if things are being shared from them or data resides in there that shouldn't. So that's an API-based protection, because we're going to connect into that environment and look at the data that's at rest, and we need an API to do that. And finally, if we wanted to understand what cloud applications were being used and just get a handle on the extent of usage, and perhaps what the risk associated with those applications might be, then I could look at the data from my inline processing of traffic, but I could also feed external data into the CASB to do that. So that would mean I could take what are traditionally kind of web proxy logs and learn from those logs what cloud applications are being used. So we begin to build a picture here of the kind of traditional secure web gateway with its additional capabilities, CASB coming into the picture as well. We talked earlier about assessing the configuration within public cloud environments, making sure that we didn't have buckets that were configured wide open or policies that allowed people access to that environment that shouldn't have it. And that's where we can have some form of public cloud security running to assess that, look at the data that's held in there, and also check the configurations. Finally, within the platform, there is this kind of legacy requirement to allow access to what might be private applications, things that services that I don't run as SaaS. So maybe these are my in-house applications still within a data center, or applications that I've developed that run within public cloud environments. So we can leverage the platform in order to connect our end users to those applications securely. So this is a zero trust model, and you might have read about or heard about zero trust models, and how they're kind of particularly relevant in a cloud world and when users are mobile, because you're authorizing users by their device, by their identity to access specific applications, rather than just giving them access by a VPN to a network. You're actually pinpointing their access and following principles of zero trust. So what's interesting about a platform like this, and I've kind of hinted at it already, is that it overlaps or covers certain market areas, but also overlaps in a couple. So we have this zero trust network access, we have security and posture management of public cloud, but the two interesting ones are here, where the secure web gateway and the CASB capabilities kind of begin to overlap. And this is something that's happening within the marketplace at the moment, that secure web gateways are creeping into that inline management of cloud applications. At the same time, traditional CASBs begin to manage things inline, and including websites, which puts them firmly in the secure web gateway space. So there's an interesting overlap here. Actually, Gartner has said that there will be some all-encompassing kind of market area here. They've called it SASE, which is a novel acronym. Gartner do like their acronyms. So SASE, the Secure Access Security Edge. And this will be a layer of security in the cloud that does the things that you see here, but also more. So other kind of inline security controls, and it will also perhaps include some of the connectivity that we see within the cloud. So technologies like SD-WAN, for example, perhaps begin to fold into this SASE market space and join up with the security controls that are evolving in that space too. So I did say it was a little bit of a complicated picture. I hope you kept with me while we walked through that, because this is a picture of of what SASE might look like, what we might see governing our access, basically becoming our new perimeter as we move away from that traditional appliance-based data center perimeter. So if we are governing access to the edge, then on this diagram, I've labeled that the secure access cloud. There will be other components in the future as well that will be relevant to our very cloud-centric mobile world. So this is a bit of a prediction slide, but it's kind of shows how a few of these things may bolt together. So you may have, a platform, perhaps like Netskope's, governing access to the internet and how it's used, but you will still need other technologies to integrate with that, and there will be value in that integration. You'll most likely always need some form of endpoint control in order to locally secure the device, and detect malicious infections and so on and so forth. You will always need some identity for the users, whether that's Active Directory or some extension of it, or whether it's some single sign-on provider or SAML-based solution. Identity will play a big part. As will, over on the right-hand side, the kind of user behavioral analytics, the reporting, the SIM tools, the security orchestration and response. So those solutions will integrate tightly in what will probably be, this future security stack. When you're done away with your appliances and your firewalls and your IPS and your web filters and so on, this is perhaps the architecture of the future, maybe, if that's not too great of a prediction. So I'm going to stop with the slides there. I did promise that I would jump into a bit of a demonstration for you just to show you some of these things. And obviously I'm going to use Netskope's product to show you that. I'm not going to hide that. So here we find ourselves within Netskope's user interface. This is actually our dashboard. I'm not going to give you a full tour. I'd rather focus on perhaps the end user kind of experience. So one of the first things I wanted to show was how Netskope learns about the cloud applications in use. So when users are accessing the internet through Netskope, I think my UI's timed out while I've been talking. Let me log back in again. When users access the internet through Netskope, we obviously gain visibility of that, and it means we can begin to learn what applications are being used. So here's our Cloud Confidence Index. I made reference to it a little earlier, and although it contains over 30,000 cloud applications that we can recognize, the ones I'm interested in are probably what we would call the discovered apps, the ones we've actually seen in use within the environment. So within my demo company here, I've seen just over 600 cloud applications being used, and I could filter this further and say that maybe I'm interested in let's look at cloud storage applications. I've seen 36 of those. Some of these we recognize. We see OneDrive here and Box as well. And if I drill down on any one of these, we'll see some of the details about the application that Netskope has and can share with you to help you kind of make decisions. Should Box be being used in my environment? Well, I can see that there's only one user using it, so maybe it shouldn't be. Maybe I could talk that user into using a different platform that other people are using. But from a kind of security perspective, is Box safe or enterprise ready? Well, according to all the criteria that we've scored it on, and you might have noticed at the top, Box scores 89 out of 100. That's the score that's it's been given. That's based on all these criteria below here. So, they have certifications, their data centers meet certain standards. They encrypt my data when I upload it to them using AES, which is great. If I look at legal and privacy issues, then, when data is uploaded, who does it belong to? Well, it's still mine or still the owner of the account. I don't lose ownership of that data. So although I may not have chosen to use Box in the environment, it seems like quite an enterprise-ready app and a fairly low-risk app for my users to be using. If I was to compare it with my favorite useless app, which is ZippyShare, we can begin to see the difference. So ZippyShare, is at the other end of the scale. It scores 4 out of 100. And again, if I saw this used within my environment, I would probably want to do something about it. So we can see the score of 4 is generally because we transfer, beg your pardon, ZippyShare doesn't really have any kind of compliance standards. It doesn't take any steps to protect my data. And certainly if I scroll all the way down to that legal section, the vendor owns the data. So if I do upload data into ZippyShare, I lose ownership of it, which isn't great, obviously. So where the scoring within the confidence index that we have is useful is when I can actually use it within policy. So if I was to define an inline policy to actually govern my users' use of the internet, then what I could do in here would be to leverage the CCI scoring to say that actually when users try to access these risky places, I shouldn't let them. So I can say this policy is for all users. I'm going to choose a category of cloud storage, since that's what we're talking about. And I can select a CCI level to apply. So any cloud storage application that we score as poor or low, I will identify, and then within my policy, I can very simply say that actually my action here should be to block access to it. So that might be my first step in building a policy that kind of blocks the really obviously bad stuff. I don't have to know what those cloud apps are by domain or whatever, because they're all in the database, and therefore that will be referenced in order to enforce this policy. And that would be quite a blanket policy that would protect against data ending up somewhere that's just bad for it to end up. But obviously I might want to get slightly more granular. So if we had a look through our other inline policy rules here, I've got some data specific rules, if you like. So here I have a rule that says if certain types of data are attempted to be uploaded to cloud storage, then I want to alert on it. So here you can see it's kind of a medical example, but I've got some patient admission reports that I'm actually identifying because those files have been fingerprinted. So I've taken a hash, if you like, of that content, that data. And if I see it being uploaded to a cloud storage application, I've set this to trigger an alert. I could be more kind of decisive and say that actually there's certain types of data that I don't want to just alert on, but actually I want to block. So here, another cloud storage rule where I'm detecting sensitive data, and I'm detecting that by looking for a classification within the file. And if I see it uploaded to cloud storage, then I actually want to block it. So I can demonstrate this because I've got Dropbox open in another tab within my browser here, and I've got a couple of files that I can use to demonstrate this with. So I have here what I deem to be a document that currently isn't marked as sensitive or anything. If you're a Harry Potter fan, you might recognize it. But this document is what I'm going to try and upload into Dropbox. So I use the Dropbox interface. I click on my potion recipe and I upload it, and that's fine because there's not any issue with that file uploading. We see it upload there. Ignore this error here. That's the file that I uploaded before this call began. But the potion recipe uploads no problem. However, if I take an alternative version of that same file, but one that's been marked with a classification. In this case, I'm leveraging Microsoft's information protection services. So not only do I have a header with internal use only marked within it, I also have metadata within the file that carries that marking as well. So here we see some custom properties within the metadata that also say that we have internal use only. So what does that mean? It means that if I try and upload the file here that has the classification in it, then I would expect Netskope to be able to recognize that within the file and prevent its upload. So let's do our upload. And here we get a notification from Netskope saying that we cannot upload this file because of that classification that it has. So that's a kind of real data-centric kind of policy. We could, of course, if we wanted to, have put a policy in place based on the activity itself. So we could have simply said that nobody's allowed to upload anything to Dropbox. And that would meet that use case where we knew there was a tool that others were using to share data with us. So we wanted to allow people to download from Dropbox so people could share stuff with us, but we wanted to prevent people uploading, so we could do a simple activity-based policy. And then, of course, at the kind of simplest level, if you like, in that traditional sense, we could employ an inline policy that prevented the inappropriate use of the internet. So this is a kind of category-based filter. So in this case, I've used gambling as an example, and we see the traditional secure gateway type capability that says cautions the user, tells them they can't go to that website. And this caution can take a few different forms. You can obviously customize it, but it could be more of a warning that then lets the user continue, as it could be for any of those cloud-based activities as well. So regardless of the controls you put in place, you'll end up with the sort of visibility that I highlighted in the slides for WeTransfer earlier, the detailed view of activity and what the user did. And should they hit some form of policy and actually generate what we would label as an incident, then we have some forensic level information about the incident we can investigate. So here you see me trying to upload my potion recipe to Dropbox. And what we have here is an incident that I have a small workflow around, so I can say I'm currently investigating this incident. But down the bottom, I can see, summarized what it was within that file, both within the document itself and its metadata that matched, in this case, our DLP engine that was looking for that phrase. And I can preview the original file and so on within this interface. So DLP is perhaps the second or third or some point down the road of your journey of kind of managing cloud. For most of our customers, visibility is the first step. So get a view of what's going on, and then perhaps start looking for very specific activities or data movements and alerting on those, and then start bringing those controls in tighter and actually perhaps start prohibiting some of those things. If you try and block everything and prohibit stuff straight away, then you're likely to hit a few false positives and prevent people from doing what they've been doing and potentially freeze some of the business activities. So you want to try and avoid that. But hopefully you can see from some of those examples the sort of granularity that you have. Now, I'm conscious we started a few minutes late, and we only have a few minutes left of our hour-long session, but I think it would be a good idea to open up for some questions. So I guess I'll hand back to Steve to help chair those questions, and I'll hopefully be able to answer a few.
Yeah, hi everyone. Thanks, Ross, for that. That was fascinating. I've learned a lot. Any questions from the floor? I think all the microphones are now open. So, any questions on the presentation? No. Okay. It seems not. So you've obviously told everyone everything they need to know, though. So I appreciate that, and thanks for the attendees. And hopefully we will talk to you all soon. Thank you.
Thank you.